All right, class. Can y'all hear me?
Yes, sir.
All right. Let's get started then. Let's check out our exam number 14 here. So we want to solve using the quadratic formula. For number one, we need to put this thing into standard form. That's what it's called. So we subtract 35 from both sides. Now we have it equal to 0. We want to write down our A, our B, and our C. So if you work a problem like this on the test, make sure you write down your A, B, and your C. I know you can just look here, but it's a lot easier to make a mistake if you're just looking here. Okay, so we have negative B plus or minus the square root B squared minus 4AC. All over 2A. So that's just the formula with the numbers plugged in. I saw in the exam, some of y'all would forget to put these, the plus minus here. And I saw a lot of small errors, you know. So try to have attention to detail and get it exactly right. All right, so we have negative is a positive 11 over 12 plus or minus. See, 11 squared is 121. Minus is a plus, and I'm gonna have to use my calculator here. 4 times 6 times 35, 840 over 12. So 11 twelfths plus or minus. See, 840 and 121 is 961. And I'm going to check the square root of 961 here, see if it's a whole number. And it is, it's 31. So since these are both in 12ths, I could put a box around the answer here, but since they're both in 12ths, we can go ahead and easily write out the two separate answers here. We have 42 twelfths and negative 20 twelfths. And both of these can be reduced. Let's see, 42 is 2 times 21. 21 is 3 times 7. 12 is 2 times 6, and 6 is 2 times 3. So we can cancel that. And we can cancel that, and we get 7 halves. Down here we have negative, let's see, 20 is 2 times 10, and 10 is 2 times 5. 12 is 2 times 6, which is 2 times 3. So we get a negative 5 thirds. So 7 halves and negative 5 thirds. Any questions about this one? All right, number 2 here is already in standard form. Our A is 3, our B is a negative 5, and our C is negative 7. So X is negative B plus or minus the square root of B squared minus 4AC all over 2A. So let's see, we have 5/6 plus or minus 25 minus minus makes a plus. Let's see. 7 times 3 is 21, times 4 is 84. All right, 25 and 84 is 109 over 6. Let's see. I don't think we can do much with 109. It's not an even square root. It's not divisible by 3 or 4 or 5 or 7, 8 or 9 or 10 or 11. So let's just leave it like that. That'll work. Since square root of 109 is just an ugly number. Now we could just figure out the decimals here, but since we're not doing a word problem or anything, this answer is just fine. So when you work these problems, you know, make sure you tell me what the A, B, and C are. Make sure you fill in the formula and then show me your work. And then preferably box your final answer. All right.
How would you figure out your 2 points if you still have a square root? Like for the second answer, how would you find them out?
Well, basically you would have, it's still ugly. You'd have 5, 6 plus the square root of 9 over 6 and 5, 6 minus the square root of 109 over 6. Those are your 2 answers. If you want them any prettier,
Okay.
you'd have to convert them to decimals.
Hey, sir. One of the classmates asked me to tell you to look at your emails. They said they're not going to be in class.
Oh, okay. I'll check that out. Thank you for letting me know.
Yeah, no problem.
Yeah. Sometimes I slack on my emails. I usually grade the exams during my first class and then check all my emails during the second class break.
If I remember correctly, you take our attendance by the quizzes and exams we turn in, correct?
Yes. Yeah. So
Okay, cool.
as long as you get those done, you know, as far as I'm concerned, you were here.
Okay, yeah, that's what I was telling them in the chat.
Yeah. You know,
Because I always post, I always take a screenshot of the exam and post it in the Discord so people can just go back and look at it.
oh, that's good. Yeah. Thank you for that. I
Mhm.
put them in the lecture notes, but I guess a lot of people don't know that, or it's just too much of a hassle. Thanks for making it easier for everyone.
Yeah, and I also try to post your YouTube links,
Oh yeah.
which I appreciate because I've had to go back and rewatch a few of them.
Okay. Well, I hope they're okay. You could probably play them like at like 1.5 speed or something, so they go by faster, right? All right. Any more questions about this exam? All right, let's look at the quiz here. I picked 2 problems. Let me see which page I got these from. I think I got them from page 131. Yeah, I think so. Yeah, I think these are from page 131 in the book. This looks funny here. Move it over. Okay, it's 3:08, so 15 minutes. We 3:18, 3:23. We'll come back and work these problems. 3:23. Oh, it's 3:09, so 3:24. All right, class, we are back. Just checking my email, and I have to submit midterm reports here soon. So I sent y'all an email reminder. If you're missing any exam or quiz grades, make sure you get those submitted to me by Friday. I'm sure all y'all probably are caught up on everything. It's the people who aren't here that are having the issues. But if you know somebody in the class that hasn't turned their stuff in, let them know. It doesn't matter how many exams or quizzes you've missed. You can still make an A in the class if you just get them done and then keep up for the second half of the semester. All right, let's look at this quiz here. So at t seconds, the height h in feet of a baseball pitched into the air is given by the function below, h of t. When does it hit the ground? Well, if this is the height, this function tells you the height, it hits the ground when the height is 0. And it's asking when, right? When does the ball hit the ground? Well, it hits the ground when the height is 0. So we just have to solve for t here. So since that's already in standard form, our A is -16, our B is 20, and our C is 8. So t equals -b plus or minus the square root of b squared minus 4ac all over 2a. So this gives us a negative over negative is a positive 20 over 32. We have plus or minus 20 squared is what, 400? Minus minus is a plus. And then I'd better use a calculator for this one. Let's see. 4 times 16 times 8. 512. All over a negative 32. Yeah. Is that right? Yeah. So let's see. 20 divided by 32 is 0.625. And there. The plus and a minus becomes a minus, and a minus minus becomes a plus. Not that it makes any difference. So we have in here 400 plus 512, which is 912. So we'll square root that and divide that by 32. So we got 0.94. Doesn't seem right. I don't know, let's see. 0.625 minus 0.94 is a negative 0.32. And a 0.625 plus 0.94 is 1.57. These are seconds. Now this negative one, this doesn't make sense because you don't have a negative time. So that means this is our answer. It takes 1.5 seconds for the ball to hit the ground. Any questions about this one? I suspect this one is pretty close to the same. Greg dives off a diving board. His height h in feet above the water is modeled by the function h of t, where t is in seconds. Find the time it will take for Greg to hit the water. Well, let's see, at 0 seconds, he's at height 12. And he either does this or he does this. A here is negative, so we know this thing opens downward. So it's either like that or like that. But we just need to find out when it actually hits the t-axis. Because he hits the water when the height is 0. So if we set this thing equal to 0 and we solve for t, see our A is -16, our B is 15, and our C is 12. So our time is -b plus or minus the square root of b squared minus 4ac all over 2a. So So let's see, we have negative over negative is a positive 15 30 seconds plus or minus the square root of, let's see, what is 15 times 15? It's 225. We have a minus minus, which makes a plus. 4 times 16 times 12 is 768. All over a negative 32. So 15 divided by 32 is 0.47. The plus minus is a minus, the minus minus is a plus. And 225 plus 768 is 993. Square root that. Now divide by 32. We get 0.98. So 0.47 minus 0.98 is a negative 0.51, which doesn't make sense because it's negative. But our 0.47 plus 0.98 is a 1.45 seconds. So right here, 1.45, that's where it lands. Well, how long it takes it to land anyways. Okay, any questions? All right. So where were we? We did that. We did this. This is where we're at on page 128 now. All right. After t seconds, a ball is tossed in the air. The ball reaches a height of h feet given by the function h of t. What is the height of the ball at 3 seconds? Well, we just plug in 3 into our equation here, our function. Our function tells us the height at a given time. So they want to know about time 3. So let's see, we got 5 plus, all right, 144 times 3 equals 432. And now we have a 9 times 16 is a 144. So 432 plus 5 minus 144 equals 293 feet. That's the height at 3 seconds. All right, to find the maximum height, we can use our vertex formula. All right, what is this graph looking like so far? We see that at time 0, it's at 5 feet. This thing either looks like this. Yeah, it's going to look like that. It's not going to look like this because I can tell that the y-intercept is not the vertex because we have a b here. If b is 0, it's only when b is 0 that you have something like that. Otherwise, we're going to have something like that. So what we can do is use the vertex formula to find out what time it reaches its maximum height and then plug that time into the height formula. So if we go t equals negative b over 2a, it's a negative 144 over 2 times a negative 16, which is 144 divided by 32, 4.5 seconds. So 4.5 seconds is when it reaches its maximum height. What that height is can be found out by plugging in that time into our function. All right, so let's see, we're at 5 plus 144 times a 4.5 is 648. 4.5 times a 4.5 times a 16, 324. So 648 plus 5 minus 324. which is 329 feet. So that's what we got when we plug this into the height formula. So that means this is 329. That point, 4.5329. All right, find the number of seconds the ball is in the air when it reaches a height of 229 feet. All right, this one's a little bit different. Okay, it's given us a height and asking about a time. So our height formula, let's see, that's our height formula. Well, we set our height equal to this 229, and now we need to solve for t. So it's a quadratic formula again, but first we have to put this into standard form. All right, let's see, let's put this one first, and then this one. Now we have a 5 here. So if we subtract 229 from both sides, we got a negative 224. All right, so solving for the time for when the height is 229 feet, we have to use this equation. So our A is still negative 16, our B is still 144, but our C here is now negative 224. So we have negative B plus or minus the square root B squared minus 4AC all over 2A. So we have 144 over 32 plus or minus the square root. All right, 144 times a 144 is 20,736. Minus 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 is a minus. 4 times 16 times 224, 14,336. This is over a negative 32. So 144 divided by 32 is 4.5. And now this big beast here, 20,736 minus 14,336 is 6,400. Square rooted is 80. Now divide that by 32. We get 2.5. I'm not concerned with this minus, again, because plus minus is negative and minus minus is positive. So I could have written this minus plus instead of plus or minus, but it's the same thing either way. So if we add them, we get 7 seconds. If we subtract them, we get 2 seconds. Which makes sense. They're asking, when is the height 229 feet? Well, 229 feet happens at 2 seconds, and it happens at 7 seconds. It happens at 2 different times. So it makes sense that we get 2 answers, and they're both positive here. All right, how long will it take for the ball to hit the ground? Well, here's our height, 5 plus 144t minus 16t squared. When it hits the ground, the height is 0. So all we do is use the quadratic formula to solve for t again. Notice this is different than what we had up here. This is the height set to equal to 0. This one is the height set to equal to 229. So they are different. We're using the same formula to get the answers though. A is a negative 16, B is a 144, and C is 5 here. So time is negative B plus or minus the square root B squared minus 4AC all over 2A. So we get 144 over 32 plus or minus the square root of 144 times 144. This was 20,736. A minus minus is a plus. 4 times 16 times 5 is 320. All over 32. And again, I'm dropping this minus here because it doesn't make a difference. Plus minus and the minus minus give us the same thing. If you want, I can flip-flop it. But it's the same result. So 144 divided by 32 is 4.5. And then 20,736 plus 320 is 21,056. Square rooted is 145 and some change. Divided by 32 is 4.53. So we get 9.03 seconds and we get a negative 0.03 seconds. So what we see here is that point right there is at 9.03. If we went back in time, this would be a negative 0.03. But we're not concerned with negative time. That doesn't make any sense. Concerned with positive time. That's the time at which the height was 0, and thus that's the time it took for the ball to hit the ground. Part E, a reasonable domain and range. Since this is a word problem, we're concerned with things that are physically possible. So the domain is your left and right. Okay, it's the time that we're considering. We don't care about negative time. We can care about time being from 0 to 9.03 seconds. The time the ball was launched until the time the ball hit. That's our domain. This means element of. T is an element of this interval. What about range? All right, well, here that's the up and down, right? Up and down. So that's the height. Well, I'm concerned with the height of 0 up until its highest peak. Its highest peak was at 329. So that's our range of interest, okay? Let's see, H of T, an element of. All right, any questions about this domain and range? Here we just want the ones that make sense physically. Okay. All right, number 20. Ball is thrown upward from a height of 15 meters with the initial velocity of 5 meters per second. Use the function h of t, where h is in meters and t is in seconds, to find how long it will take the ball to hit the ground. Graph this function below. Okay, well, at time 0, it's going to be at 15 meters. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom. That's our y-intercept, right? So h of 0 is 15. Our a here is negative, so we know this thing opens downward. It might do this. It might do this. First, let's find, because they ask us first, find out how long it takes the ball to hit the ground. Well, if we set this thing equal to 0, the height equal to 0, then our A is this, B is 5, and our C is 15. So if we use the quadratic formula, we can find out the time at which the height is 0. So we get negative b plus or minus the square root b squared minus 4ac all over 2a. So let's see, a negative over negative, that's 5 over 9.8 plus or minus square root of 25 minus minus is a plus. Let's use our calculator here. 4 times a 4.9 times a 15 is 294 over negative 9.8. So 5 divided by 9.8 is 0.51. Now 294 and that 25 is 319. Square rooted, divide by 9.8, we get a 1.82. So if we add these, we get a 2.33. If we subtract them, we get a negative 1.31. So this is the positive one, is the one of interest here. Since these tick marks are so small, let's use each tick mark to be a tenth. So 1, 2, 3, 4. This is 0.5. 1, 2, 3, 4. This will be 1, 1.5. 1, 2, 3, 4. This would be 2. 1, 2, 3, 4. This is 2.5 here. So 2.33. 1, 2, 3. Right about here. 2.33. Just so our graph looks prettier. So this is how long it will take the ball to hit the ground. 2.33 seconds. But let's go ahead and graph the function because they asked us to. So we don't know, does it look like this? Does it look like this? By the way, the negative 1.31, that would be over here. But we're not concerned about that side of the graph. It's not part of our reality, if you will.
I was just about to ask about that. Thank you.
Sure. Yeah, we're not worried about that. So we just want this stuff in quadrant 1. So what we need to do is find our axis of symmetry. So we'll do our negative b over 2a. So it's a negative 5 over 2 times a negative 4.9, which is 5 divided by 9.8, which was 0.51. So that's going to be right about here. That's our axis of symmetry. To find out where our vertex is, we plug that into our function. All right, let's see, we got 0.51 times a 0.51 times a 4.9. This is 1.27. And then a 0.51 times 4. So 2.04, 15. Oh, and this one's negative. So 2.04 plus 15 minus 1.27 is 15.77 feet. So since here's 15, boom, there's our vertex at 0.51 and 15.77. So now we know this thing looks like this, roughly. We could make it a little bit better, actually, because we know this point here. Let's see. We know its mirror point is over here. So that mirror point will let us make it a little more accurate anyways. So it looks something like that. I'll draw this thing. Mirror. point. I could figure out exactly what it is, you know, we're doing some math, but we'll just eyeball it. So that's about as accurate as we can draw a graph by hand here. All right, any questions? Okay. There's some homework, 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 more homework. All right, problem solving using the root method. Page 133. So this is x squared minus 9. Okay, remember x squared looks like this, right? All we've done is taken 9 away from all the x squareds. So all the outputs, we've taken 9 from it. That's why it's just x squared, but shifted down by 9. Okay, now if we're going to find the roots where it crosses the x-axis, we'd set this thing equal to 0 and solve. Quadratic formula is one way, but in this case, notice there's no b, there's only an a and a c. So if we add 9 to both sides, then we can square root both sides. And right here, the absolute value of x, if you're looking at this, you can tell, oh, x can be a positive or negative 3, right? And you jump right here. Well, the math that does that, when you take the square root of both sides, the square root of x squared is the absolute value of x. So if the absolute value of x is 3, then x has to be positive or negative 3. Most of y'all jump to this step in your head, but this is the abstract part in between the x squared equals 9 and yx is plus or minus 3. So notice this thing is symmetric right down the middle at the y-axis. All right, it's because all we did was take x squared and shift it down by 9. Let's do another example. All right, this looks like x squared but flipped upside down, right? This was x squared. All right, well, there's also a 4 here. What they did is they took x squared and notice that it's skinnier, right? If you flipped x squared upside down, it'd look like this. This thing is skinnier. That 4 there stretched it vertically by a factor of 4. This minus sign flipped it upside down. And then this 9 shifted it up 9. So those are the 3 things that have been done to x squared to end up with this. But notice you're still symmetric right down the middle. Your vertex is on the y-axis. All right, and because of that, you can use the root method. There's no b in there, just an a and a c. So if you set it equal to 0, move that 9 over. All right, or get your x squared moved over. Divide both sides by 4. You get this. X squared equals. Now take the square root of both sides. All right. Square root of 9 is 3. Square root of 4 is 2. The square root of x squared is the absolute value of x. So you end up with positive and negative 3/2 for your roots. Okay. All right, this guy here, x squared minus 12. This is x squared, just moved down 12 units. All right, so to find the roots, set it equal to 0, right? You just throw the 12 over. You got x squared equals 12. Square root both sides. Square root of x squared is the absolute value of x. 12 here is 2 times 2 times 3. So we can pull a 2 out and leave the root 3 in there. So this is your exact answer, or if you want to do the decimal, you can approximate it. And those are your roots. Notice this guy, symmetric on it's about the y-axis. This one's the same, but a little different. Notice this guy, again, symmetric down the y-axis. Notice it doesn't cross the x-axis at all. There are no x-intercepts. So if you set this equal to 0 and try to solve, well, you subtract 4 from both sides, you end up with this. When you take the square roots, we have the square root of a negative number. Remember, the square root of -1 is your imaginary number I. So you end up with x is positive -2i. Those are your roots. They're just not on the x-axis because they're not real numbers. Okay. Remember your discriminant, that thing that was inside of here? This guy is your discriminant. So in this case, there is no b. B is 0. A is 1 and C is 4. So you get a -16 here. When your discriminant is negative, that's when you get imaginary or complex valued roots. And when you have those, you don't have any x-intercepts.
Quick question.
Yes, ma'am.
So if it has an I and was a negative number and you wanted to graph it, you would graph it as a positive?
Well, you can't graph the I, the imaginary or complex numbers. You can't.
Well, yeah, but it was previously negative, so you would do it as a positive?
You're talking about right here?
Yeah.
All right, when you square root both sides, all right, the minus is inside the square root. This is a -1 times 4. Or the square root of -1 times the square root of 4. This guy is I. Square root of 4 is 2. So that is 2I. Where the positive and negative comes from is from the absolute value. When you drop the absolute value, you have to put the positive and negative in.
I got that, but my question is more like if you got the answers and you had to graph it, like if it had an I in it, how would you graph?
That's the thing, is you can't graph it. What this does, these roots, they tell you where it crosses the x-axis. This graph doesn't cross the x-axis, right?
Oh, okay.
Does it make sense?
Yeah.
If you
I was
get an I in
confused.
there, that means it's either up here or it's down here. It means it's not crossing the x-axis. There are no x-intercepts.
That makes a lot of sense. Okay.
Well, it didn't make sense to people back then that invented this either. That's why they called these imaginary numbers. All right, but that was before they knew how to graph stuff as well. They were just trying to find solutions to equations like this. You know, when you have the number 1 is a real number, the number 4 is a real number, but when you set this equal to 0, which is a real number, when you solve for x, you get these aren't real numbers, right? They didn't know what to do with them, so they just called them imaginary numbers and forgot about them. But now we realize that although it's an imaginary number, they represent real things in the real world when we do our physics. So they're very useful. They're just as real numbers. It's just the term real number had already been taken. And back then they didn't know how to make any sense of them. Usually you have a complex number is like this, where this is your real part and this is like your imaginary part. Together they make a complex number. And so when you're doing equations, basically the real part of the equation will tell you something about a physical property, and the imaginary part will tell you something else. Like in electromagnetism, this might be the electricity and this might be the magnetism, and they're interconnected. They play on one another. All right, square roots. These are easy. Just got to watch out for those imaginary numbers. So here we'll add 16 to both sides. Square root both sides. The square root of x squared is the absolute value of x. Square root of 16 is 4. So we get positive negative 4. And we drop that absolute value. Same thing over here, add 100 to both sides. Square root both sides. And drop the absolute value, plus minus 10. All right, here, subtract 25 from both sides. Square root both sides. Now we have this minus in here. All right, so that's going to give us an I. But square root of 25 is 5, but we have an I here. We have a positive negative 5I. So don't forget about those minuses, right? That when that minus is inside the root, you're going to get an I. That's an imaginary number. I mean, you do enough of these, you can look at this and just go, oh, the 25 is going to be negative. You're going to root it, so you're going to get a 5 and then an I. Should be able to just write down the answers. But for exams and quizzes, you have to show your work, okay? So this one over here, if we subtract 88 from both sides, we get this square root. All right, square root of 81 is 9, but that minus gives us an I. So x is positive negative 9I. Okay, this one, let's subtract 7 from both sides. Square root both sides. So we get a root 3. That minus sign gives us an I. So x is positive negative square root of 3I. Over here, if we add 4 to both sides, now we square root. The square root of negative 1 is I, exactly. So x is positive negative I. All right, let's see, divide both sides by 6. Let's see, 90 is 2 times 45, and 45 is 9 times 5. 9 is 3 times 3. So get rid of that. This is 15. So x squared equals 15. So square root both sides. I can't do anything with 15 because it's just a 3 times a 5. So x is positive negative square root of 15.
What about the 6 in front of the x? Do you not do anything with that?
I divided both sides by 6. That's why I got the 90 over 6.
Oh, okay.
Yeah. All right, this one, subtract 99 from both sides. Multiply by negative 1. Divide both sides by 4. I don't think we can reduce that fraction. If we square root, let's see, what can we do with this 99 here? 99 is 3 times 33. 33 is 3 times 11, right? Square root of 4 is 2. You pull those out, we got 3 root 11 over 2. Okay, so we're looking at 3 root 11 over 2. So x is positive negative 3 root 11 over 2. Okay. All right, let's see, this one. Multiply both sides by 4/3, right? I do a 4/3 here and a 4/3 there. This is, let's simplify this. 12 is 3 times 4. This is 16. So square root both sides. Square root of 16 is 4, so x is positive negative 4. Remember, you can always plug these numbers back into the original equation to test, see if they're correct or not. Let's see, it's past 4. Do y'all want to take a break or do y'all want to finish class early?
Finish class early.
Finish class early. Anybody opposed?
Yeah, I'm good.
All right, well, let's do this then. All right, if we subtract 16 from both sides, we get that. Divide both sides by 49. I think we can do anything there. Square root both sides. Let's see, 8 is 2 times 2 times 2. That minus gives us an I out here. 49, the square root of 49 is 7. We can pull 2 of those out. Boom. We still have 1 left. So x is positive negative 2 root 2 over 7i. Okay, subtract 5 from both sides. Square root. 12 is 2 times 6, which is 2 times 3. So we pull a 2 out. So x is positive negative 2 root 3. For number 12, put 41 to both sides. Square root. I don't think we can do anything with 41, can we? 41. Nah, we'll just leave it like that. These are our answers. Okay, let's see, we have negative 8x squared. If we add 6 to both sides, gives us that. Multiply through by a -1. Let's divide by 8. Gives us 3. Square root both sides. So x is positive negative root 3. But here, if we add 17 to both sides, it gives us 23. Square root, the absolute value. We can't do anything with 23 because it's prime. So we got 2 more. Throwing in some fractions just to make it ugly here. Same thing though. Let's see, we got 1/2 x squared. If we add 29 to both sides, we get this. Multiply both sides by 2. Square root both sides. Square root of 64 is 8. So x is positive negative 8. See over here, subtract 1/3 from both sides. Now we multiply both sides by 4/3. So we have x squared equals a negative 4/9. Square root of both sides. We have Square root of 4 is 2, square root of 9 is 3, and that minus on the inside gives us an I. So x is positive or negative 2/3 I. All right, some word problems, page 136. In science class, students were asked to create a container to hold an egg, which they would then drop from a window. The function h of t gives the container's height in feet after t seconds. How many seconds will it take for the container to hit the ground? Well, here's the height at any given time. It hits the ground at height 0. So we just need to solve for the time. Apply by -1, so t squared is 25 over 16. The square root of t squared is the square root of 25 over 16. So the absolute value of t is 5/4. So t is plus or minus 5/4. We're only concerned with the positive time, not a negative time in which it was at the ground, because that doesn't make any sense. So just like the other word problems, except it's easier because you can use the root method because there is no b. B is 0. All right, here's an equation. Solve it using the quadratic formula. Well, a is 9, b is 0, c is -5. So we got a negative b plus or minus the square root of b squared minus 4ac all over 2a. That's 0. So we get plus minus. That's 0. Negative negative is a positive. Let's see, 4 times 5 is 20 times 9 is 180. 9 times 2 is 18. Well, let's see, 180 is 2 times 90. 90 is 2 times 45. 45 is 5 times 9, and 9 is 3 times 3. So we can pull a 2 out and a 3 out. 2 times a 3 make 6. So we can reduce this 6 over 18. Just positive negative root 5 over 3. That's using the quadratic formula. We use the root method. We can add 5 to both sides. Divide both sides by 9. Square root both sides. We get the absolute value of x is the square root of 5. Square root of 9 is 3. So x is positive negative root 5 over 3. All right, the differences between the two. Basically, you can just look at this and go, oh, I have to move over 5, divide by 9, and take the square root. So I'll end up with a root 5 over 3. With the root method, you can do this in your head. The quadratic method, the quadratic formula method, you can't really do it in your head. Okay. So those are the differences. If you can use the square root method, use it instead. The quadratic formula is only when you have really ugly numbers. So when can you use the square root method? It's when b is 0, right? Because when b is 0, you're left with this, which means you can do this. That's what your, the root method ones have exactly this form. They all look like that. A number times x squared plus a number. And your answer is always this. Sometimes C or A might be negative. They might be a fraction and so on, but this is always your answer whenever you do the square root method. All right, here's the graph of two functions. Which one can you use the square root method? This one, because it's centered right here on the y-axis. This one over here, b is 0. All right. Over here, this one is shifted. B is not 0, so no, you can't use it. When you have the ax squared plus bx plus c, all right, think about x squared. That's your basic function, right? The a stretches it vertically, all right? The c moves it, right? Moves up or down. Okay, the a stretches vertically. And the b shifts left and right. All right, so if this thing is not centered on the y-axis, that means it's been shifted, which means there is a b, which means you can't do the root method, okay? Right, remember your negative b over 2a. If b is 0, your vertex lies on the y-axis. Oh, you get some homework up in here. Homework. All right, page 139. All right, factor by using the GCF or the grouping method. Well, here the GCF is 10. You can pull a 10 out. Okay. Over here, you can pull a 3t out. So you get a t plus 2. Y'all remember this stuff? Factoring. 3t times t is a 3t squared. 3t times 2 is a 6t. Look at these. You got an x squared and an x to the 5th. I know I could pull an x squared out. But let's see. 15 is a 3 times a 5, right? And 21 is a 3 times a 7. That means I could also pull the 3 out. So if I pull that 3 out, I get this. All right, this was our GCF. We can do the same thing over here. We could pull an x to the 4th out. But see, 24 is 2 times 12, which is 2 times 6, which is 2 times 3. 30 is 2 times 15, which is 3 times 5. So we can pull a 2 out and a 3 out. A 2 and a 3 gives us 6. So we're left in here with a 4 and a 5x cubed. We can check. 6 times 4 is 24. 6 times 5 is 30, right? And we got an x to the 4th and an x.
How'd you get 6?
The 6. I pulled a 2 out.
There's 3 because there's 3 2s, or
I pulled a. Both of these have a 2, right?
right?
So I pulled those out to make a 2 out there. But they also both have a 3. So I pulled the 3 out. So the 3 times a 2 is a 6.
Oh, okay,
All right.
makes sense. I thought you added them. I was like, well, that doesn't make
Or you can
sense.
just look at the 24, the 30, and recognize, oh, those are both divisible by 6, right?
Mm-hmm.
That's why you have the 4 and the 5 in here.
Okay. I got it.
Right, now these down here, I think this is where I left off. I got here and I was like, yeah, we can pull a 6 out. This one doesn't have an X in it, right? I can pull a 6 out. I get X squared minus 4X plus 5. All right. And then I was trying to factor these instead of that's the 6 is the GCF, but doing this grouping method, I looked at this and I was like, I should be able to factor that. There should be an X and an X because we got an X squared. And I was like, okay, what do I need to put here and here, right? We need two numbers that multiply to give us 5, but add to give us -4. And I was like, maybe 5 and 1. But if we did that, I get a 5X and an X would be a 6X. So it's not that. I was like, well, maybe I do a -1. In which case I got a 5X. No, I did this. Now I have -5X and a positive X. That gives me a -4X. But the problem is this gives me a -5, not a +5. All right. So I couldn't just eyeball it. There's a method called grouping, which I always forget how to do it. And I have to look it back up every time. And in the last class, I looked at my little instruction sheet that I made for myself last semester. And the trick here, here's a new example. What you do is something like this, is we take the middle term and we rewrite it as a sum of two terms. In this case, we rewrote -X as a -5X and +4X, because -5 + 4 is a -1. And then here you can pull out a 5X, and here you can pull out a 4. In which case you get this. Now notice this and this are both multiplied by an X -1. So we have a 5X and a 4. They're both being multiplied by X -1. So now we have this nice factoring. But the problem is how do you figure out which two numbers to use? How do you rewrite this middle term? The trick is rewrite the middle term as a sum of two terms whose product is A times C. So what we need a P and a Q, where P times Q is A times C. So we're trying to find, this is our P and this is our Q. All right, they need to multiply to be the same as these two multiplied, but they have to add up to B. So our P and our Q have to add up to be B. So I want to review this before we move on so that I can explain it clearly and quickly so it'll sink in, because I forget every time. I remember this stuff, but I want to review it a little bit before we cover it. So I'm going to stop us right here for today, if y'all are okay with that.
Sure.
Yeah, we can try. Let's try one real quick. Our A is 6. Our C is 30. So our A times C is 6 times 30, which is 180. So we need two numbers, P and Q, where P times Q is 180. But we need P plus Q to be -24. All right. So actually, you know what? Let's just look at this. Forget about those numbers. We've already pulled out the 6. So in this case, our A is 1, our C is 5. So A times C is 5. So we need a P and a Q where their product is 5, but they need to add up to be -4, or B. So two numbers that multiply to be 5, but add to be -4. Well, we got one. No. Add to be 5. No, add to be -4, but multiply to be 5. Well, the only numbers that add to be -4, let's see. I don't know. This one's hard.
Negative, no, because it's negative and a negative equal a positive. So yeah, no.
Yeah, the only numbers that multiplied to give us 5 would be like 1 and
Times
5, or well, that's it, 1 and 5, right? Or -1 and -5. So I think this one is just not factorable. If we factored it, we would get really ugly numbers. So this grouping thing where you do these PQs and stuff to make these come out pretty, like X, X, and pretty numbers here and here. This one isn't one of those. This one you get ugly numbers. So I don't think this grouping method works. That's why I got stuck. I thought I was just having a brain fart. I was like, shouldn't it be pretty? No. Because if let me plug this into a factor.
What does P and Q even stand for? Because I remember being told as a kid, mind your P's and Q's.
Well,
product and something, right?
in this case, they don't stand for anything. We could have used Z and L. They're just 2 letters. What we're doing is, if we're factoring this, we're taking this middle term and we're rewriting it as 2 numbers. So instead of -x, we write it as -5x plus 4x, because they add up to -x. Well, where does this -5 and this 4 come from? The -5 is our P and the 4 is our Q. So that's what we're trying to find out. Is it's just the name for 2 numbers. All right. And where they come from is, see, the sum of 2 terms, P and Q. So P and Q have to multiply to give us A times C. So PQ has to be AC, and their sum is B. So P plus Q has to equal B. So that's what we're trying to figure out, is a P and a Q, just 2 numbers that if you multiply them, you get the same thing as 5 times 4. But if you add them, you get -1. All right. So in this case, -5 times 4 is -20, which is the same as A times C, right? And 5 plus -5 plus 4 is a -1, which is this middle number. All right, so what we do is we look at A times C and we look at B, and we're trying to find 2 numbers. Usually you look at the A times C and be like, well, what are the possibilities? You either have like 1 times 20, 10 times 2, or 5 times a 4, where one of these numbers is negative. Now, which one of these actually add up to give us a -1? Well, it's this one when 5 is negative. So we look at that and we go, okay, our P is -5 and our Q is 4. And then we rewrite this like that. It gets easy after we do a few examples that actually work out, because this one was a bad example because it doesn't work here.
We'll be doing this next week.
Yeah. So if I do this, let's see, factor. If I plug this into Google, where's my minus sign? Minus 4x plus 5. Give me my solutions. Okay, you see in this case, that is going to be x minus the square root of 5 and x plus the square root of 5. All right, these aren't pretty numbers. That's why this grouping thing doesn't work. I would never thought of P and Q as being square roots, you know, this only works out for things that factor where you have whole numbers here. All right, so I'm thinking in the book, these, we don't use that method yet. Back when it says completely, this is where they all work out pretty. So I was trying to make them work out pretty before they were supposed to work out pretty. But that's it for today, y'all. Till Monday. Oh, I think I told y'all I got to do the midterm reports. So if you have any missing exams or quizzes, get them done before Friday. Oh, we have to have the exam. That's right.
I was about to say. I
Uh,
was like, no, it's here. All right, goodbye.
all right, see ya. There we go. Okay. Here's your exam. I put the page numbers that they're from for your convenience there. And that's it.
Cool. Thank you, sir.
Yeah.
You have a great weekend.
Y'all too. Enjoy.
We would use the quadratic the formula, right? I just said it messed up.
Oh, for this exam?
Quadratic.
Yeah, you'll use the quadratic formula for these.
Yep. Just wanted to be sure.
I think maybe number 2, you might be able to use the root method because there is no B.
Okay. I bet. 2. Cool. Thanks, sir.
Sure.